Hi, it's Gadget UK here again, back for part 2 of Cather's A3000 repair. In part 1 we dealt with a lot of the corrosion on the board, but there were still lots of damaged traces and wires and things, and we had a lot of stuff to stick back on there. Well, days later, I'm spending way more time on this than anything I've ever worked on, actually. It's turned into a bit of a labour of love. I mean, well, war, love, war, I don't know, you decide. The battleground here is horrific. But anyway, tinned everything up around here. We've got some, totally corroded through bits around here. Believe it or not, many of the connections around here are okay. You can see I just start to put some more thread lock on. I'm using thread lock because it's just like solder mask. It glues just the same, but it's more robust. But you can just chip it off. It's not a big deal. But you can see, I've got some all over these wires here. Just tested the connection to the Denise here and the Paula correctly. All these fine traces, all working correctly. The chip over there's got 3 connections that run from 3 of the wires there, actually, because they are the traces are balked on the top side. Trying to fix them on the top side, I did that, and then they break off. So it's like it's easy just to have fixed wires on the underside for some of the fixes there. There are other places where I've managed to put a little trace on the top and fix it okay, a little piece of coil wire. Anyway, so all of this stuff here is covered with the solder mask. Let's call it solder mask. It isn't solder mask, but it's as near as the same thing. Once that's dried, and this is the thing, I'm going to let that dry overnight now. I'm not going to do any more on this area. What I'll probably do now is shift my attention to down here, actually, because there's very little to do here, just 1 or 2 traces around here to fix, and I can reinstall the resistor array. I'll check it first, get a socket on here after I've fixed the 1 or 2 traces, and then start to solder mask all up around this area. Yeah, so I'm going to leave all the real-time clock stuff exposed. I'm just going to leave this bit here. I'll get some solder mask onto that bit of tinned copper later. Obviously going to need to pierce some holes through for the new caps where required. But once I've done that bit, I'm quite comfortable. Everything here is kind of alright. We're then kind of left with the scary area where there's lots of traces balked around here. The corrosion seems to have gone left and done most damage around here. So the 4 caps that are on Paul here, 2 or 3 of them I think are just not connected. The traces are disintegrated on the top side. The stuff on the bottom side here is fine. We will have patched the 1 or 2 traces here as I work on this area. So there's just a few things to check around that sort of vicinity there, wires going through properly, etc. Are the traces okay? And then it's going to be a case of just making sure I work out what traces on these above Paula here need fixing. But I've got enough space actually at that point to actually get the Paula back on, to test these wires here, remove the stuff to the left here. We're going to need to do that, I think, including this ferrite probably. And fix all of the stuff there. That's where there's loads. There's going to be, I don't know, 8, 9, 10 wires around that area, I think. And if by some minor miracle that it goes according to plan, I then need to obviously flip the board over and fix the traces and all that stuff on the underside as well, and get some more solder mask on. And at some point around then we should be able to test, I think, even without these the stuff here. I think one of the chips here is definitely needed, and that's going to be, is it a 174 or 74? I think it might be that one. We got 2 of these rams here. I forget which positions they went in. 2 of the frame rams, and then a 74 series, and that 74 series I think goes here, which is super corroded. But once that's on, we might be able to try it just with RGB. We might be missing a colour or something like that, and obviously then the de-interlace stuff is the final bit. And in order to do that, I'm not ruling out that we may need to take this line ram off because it's super corroded here. We may need to take both of these off, and we may need then, we might have audio problems, we may need to remove a chunk of stuff around here. It's like, I'm not enjoying this. This is so stressful to work on, if I'm honest, and highly time consuming. But hopefully if I just lift this up, you can see that with the solder mask, it's not going to look too bad actually. These silver bits when they're covered with this green. The key is it's just not missing anything, and it's after we get to the point where we test, if we have a black screen or something, it's then going to be super time consuming to go around, you know, all of the stuff around here. You know, you can assume that Agnes and Denise here might be where the connectivity issues lay, but it could be something around one of these PAL/GALs here, some of the 7.4 series, maybe the chip RAM, and it could even be a trace leading further in. You know, something around here may not have a connection, or there might be a bit of corrosion somewhere that I can't see that's, you know, corroded a via or a trace up here. So yeah, things like this are much easier when you've got board layout on Amiga PCB Explorer. I really wish someone would put the 3000 in there. So as you can see, getting the capacitors and stuff back in here now, testing everything as I go along, all of the traces all around the area, and obviously I tested thoroughly underneath the sockets and things, that because these are all being replaced here. There's a jump cut, by the way. I had to remove that Loctite. Do not use Loctite. I am sorry if I ever suggested using Loctite, and you know what, it can be a good idea if you get the stuff that sets in open air. The stuff I'm using here is the stuff that only dries when it's in a thread, yeah, when you've got no oxygen. So I had to remove it, and I had to replace the Denise socket again. I had to replace this GAL socket again, because those were the two places where it got under, and it wicked up the pins and locked the chips into the socket. So I cleaned that chip up. Obviously the chip wasn't in. Anyway, that cost me about 2 hours of messing around. No lost pads or anything. So yeah, anyway, it was just one of those things. You can see I've soldered this cap on here, got a tiny bit of flux onto the solder point there, and you're going to get a tiny little bit of solder and reflow from this side. You just get a much cleaner job. It just looks so much better. That's it. You can see a nice shiny solder point there. I'll do the same on that side, then clean around it. I'll have a toothbrush around this area as well. But yeah, so testing every via, every trace, everything around here, and then inspecting on the other side as well to make sure there's nothing you know, of concern there. The next thing you can do though is start to I fixed the trace here, I think, with a piece of coil wire. I'll show you that. There's 1 or 2 places I've done that. I can get the socket back on here, get its cap back on, get the resistor array back on. Yeah, we're kind of getting there, aren't we? I'm going to use some nail polish, I think, to cover some of these traces, but I want to make sure it's working before I do anything like that. You could argue you should do that before you start to stick some of these things down. You know, we've got a little bit of copper underneath that cap there, but it really isn't a big deal if there's just, you know, a ground plane and VCC rail where there's a bit of copper exposed, like here, for example. But yeah, everything is good around here, including, you know, the connections for that 47 ohm resistor through this wire here that comes up to somewhere on Denise here. I'm amazed, actually, that it seems to be going well. It's just really, really time consuming. So a number of the components I took off I've cleaned up. This resistor array here wasn't too bad. It was fairly shielded because it's like behind a load of stuff here, I think. But yeah, cleaned up the pins on it, and now just testing on meter here. Hopefully you can see that resistance mode. So from pin 1 to every pin on it, yeah, 1k. Hang on, it's pretty precision that as well, actually. 1k, yeah, almost spot on 1k. But before I do that, I will just double check everything around here, including the traces for this IC. Quick look on Super Macro. Yeah, I apologise, the board is a state. But yeah, so you can see a single wire fixed there. Sorry, the lighting's awful. So yeah, it's just on the trace, a piece of coil wire. And again here, it comes out of the wire and down a trace that goes down towards where Paula goes. So I'm just going to get a tiny bit of the green nail polish on there. I've got some clear stuff covering like things like these traces where they're visible, but these are all going to be under a chip. So I'll get a bit of the green stuff just there over and around that wire, just to help support it, and the same around that wire there. And as you can see, the wire below it is blocked as well. You need to block any wires in the area. But yeah, this area is where I'm going to be moving on to next, because we won't be able to boot without this. Once we get that done, I'm tempted to try it actually. We'll get a Paula on. And the stuff around here, can you see the pins? It's going to need recapping anyway. I don't know whether I'm going to do the recap. I probably will do. That might be a separate video, I think. Yeah, and all up here, look, but I have managed to clean with some success around here. We've just lost the surface. That chip there may need to come off, because it looks awful. And again, these probably need to come off. But around the amber socket here, no issues at all. As you get further down here, it's not too bad at all. Just a little bit, as you can see, of the surface of the trace has worn off. Still some corrosion, needs cleaning up, and we got a bit of greeniness into the audio sockets there. So all the 7.4 series tested so far are okay. Look at the state of this one. This is the 174, it's pretty close to the battery. Anyway, I'm going to clean it up anyway, test it in the tester. I've probably got a replacement LS174, so this is one that I'll probably replace. And I'll probably replace the F86 because the legs are just a bit short on it, but tested out okay. And I'm sure you've seen it all before, but it's a case of multi-pass cleaning process here. You know, fiberglass pen to start with here, wire brush, vinegar, scratchy tool. Yeah, a number of washes and stuff, but yeah, this one's pretty bad. The green extends right up to the very edge of where it goes into the chip, so I'm sort of suspecting that if I test this one on the tester in a minute, it's probably going to be faulty. And I will get braid and flux of stuff onto it as well, once I've got all the green off it. Most of the 7.4 series stuff's still easy to get hold of as spares, but some stuff's not, like some of the F stuff, some HCT stuff can be a bit fiddly, or AS stuff, the advanced shock key. I'm not sure there are any around the area I'm working on here. They're all either Fs or, in this case, LS. LS being the most common alongside HC. Yeah, so at this point I used the TL866 to test the 7.4 series actually. So the 373 is okay. The F86 XOR, that was okay. The flip-flop came out okay. And the inverter, it actually failed, which was no surprise really, because I think that was perhaps one of the most corroded. So getting towards the point we can test, this is Paula, might need to swap this out. It's pretty green. Just on the edge, it kind of looks a bit greeny. So yeah, just using a cotton bud initially with a bit of vinegar here. I'm pretty sure this has been cleaned with vinegar already. And then I get the fiberglass pen onto it. And we'll just see what it looks like after that. It kind of looks superficial actually. It doesn't look too bad on this. Right, next day clean with some IPA. Yeah, so clean the inside, the legs as well, you know, putting it flat like that and then use the fiberglass pen. It's come out pretty clean actually. I think this is hopefully going to be okay. Yeah, the print's quite hard to read, 43rd week of 1991. You may or may not be able to see that. Anyway, you can see the pins, I think, look okay. So I did the same thing with the 837-2B there, Agnes, the 2 mega one. So that's back on, and I've just cleaned up Super Denise here. So the interesting thing with this is, can you see, but the legs here, they're bent. They've got like an indent into them. Yeah, it's been pressed in really hard into a socket when the legs or the chip's not been correctly aligned, so there's like it's sagging down all the way along here. So yeah, I'm going to try and straighten that out. One way you can do something like that is to get a flat ruler, because the inside is squashed in, a flat ruler, and sort of start to press like that, move along until eventually you can get the ruler flat into the gap. This one from Dave Jones' EEV blog is just the right dimensions. You can see, look, it's starting to fit in that side, look. So you sort of just gradually ease it into the ruler and it pulls the top part of the pin away here, and then you can press down with something flat and you should get a perfectly flat pin like got that side there. Yes, the pins are a lot straighter, but I just remembered something. Kath has sent me this really cool 3D printed chip leg straightener. So you've got the smaller profile there, that won't fit, a larger profile on that side. So we just get the chip there, and it's just big enough, look, and we squeeze. So So yeah, I really like that. Hopefully that's going to do a good job. Let's have a look. Wow. That's done an incredible job. That is fantastic. Yeah, well, I might not have particularly enjoyed working on this 3000 very much. It stressed me out. It really has, more than the Archimedes did. But that is really nice, because the profile now is absolutely perfect there. That's totally straightened that out. So many hours later, we are almost there now. So yeah, I did a deliberate upgrade to this board. It was not a mistake. This is not me making a mistake. I've socketed the capacitor there. That's a deliberate thing. I didn't make a mistake. Definitely didn't make a mistake there. Didn't put a socket that was too big there. That is deliberate. I definitely upgraded this by adding a socket for that capacitor. It makes it easy to service. You can just take the cap out, put a new one in. Isn't that cool? Yeah, and I definitely didn't make a mistake. It wasn't a mistake. Yeah, so I've fitted a ferrite there. This chip we tested out in the program I showed you. It's okay, but I'll order a replacement. The 04 was balked, as you saw testing in the program again, the TL866. New cap here, new diodes, old resistors, new caps, new old resistor. All the caps around here are all new, including the one in the socket. Isn't it cool? Yeah, the thing is, you see, the position for the cap there is perfectly in line with the chip. So, and the spacing is 2.54 pitch. So you can, when all the silk screen's gone, you're like, oh, it needs a socket that size. Well, actually it doesn't. The cap went on the end. Some of these others, like they're saying, there's a bigger gap between that and its cap. But then again, there's a cap missing there, actually, for the real-time clock. And we've got missing the crystal. And what else are we missing? Obviously missing the 04 here, that's the one that's balked, and there are 4 or 5 traces around there that I now need to fix. That's the final bit here. We've got some bits of nail polish that I may remove, because I've got some solder mask. I've been experimenting, trying to set it with some UV. I think I might actually just clean that off carefully and stick a little bit of this on instead, because it's a bit more structurally secure. Nail polish will go hard, you know, and you can chip it off. You can get it off with acetone or even IPA with a bit of rubbing really easy. But solder mask paint like that sets a wee bit harder. I mean, that could be a good thing, it could be a bad thing. It's good for securing the wires, and that's all those 2 blobs there are for. But anyway, yeah, so Super Denise back on, Agnes back on, Paula back on. All the stuff here, that needs replacing really. It's a bit short legs. That probably needs replacing. Oh, does it? That might be a new one, actually. I think that's a new one. Yeah, and obviously that really needs something with longer legs. We're missing the RAM here. I'm not bothered about that just now. I just want to just get this 04 back on. I'm assuming I need that to boot, and see, is it actually working. Right, I'll show you the horror story under the board in a minute. Yeah, 2 weeks of my life spent on this. So is it going to work or not? I've just connected the back plane. Got the custom power connector here. I'll show you that. It goes to an ATX power supply. You need to make sure that's not shown on the board. And if I point you with the screen, now what I would like to see is anything other than just a black screen. I'd like to see RGB sort of come up here. So any colour is a welcome colour, actually. So just checking everything. There's no shorts or anything. And I'm just going to put my hand just near Agnes and Denise and just hold over there. I've got the wrist strap on. Press the power. Ooh, green screen. Yeah, oh, hang on, and it did a reboot. That's normal. So yeah, now I have just noticed we haven't got all the chip RAM installed. Is that what it is? Is there a jumper for chip RAM, and the fact we haven't got the other 8 chips there is the issue, or is there a fault? So anyway, that's good news though, isn't it? We are getting something. So RAM installed, cleaned up the legs of every single one of those, and I had to straighten quite a few pins. Anyway, if this doesn't work, I'm going to be really cheesed off. Alright, switch it on, see what happens. Oh, God. Green screen, oh joy. I like the way the TV's decided to switch itself off right in the middle of testing there, and even though, despite the fact I had a video signal, it still shut down anyway. So yeah, I'm going to have to get a diagram onto it. Yeah, so the green screen could be a connection around Agnes. Hopefully it's somewhat simple. But you know what? I pretty thoroughly checked everything as I went along. I'd be amazed if I've missed something there. Right, so I appreciate it's been a bit vlog in this video, really just updates and things. But as I said earlier, I've said it all before, yeah, I've removed this RAM here. There's something intermittent around here, and it's a bit greeny just around there. I'm going to take that one off next, and then maybe these two. But if you press around here, you get the green-black flashes instead of green-red, green-red, green-red. So it could be one of the traces somewhere, or wires that I've, you know, sort of tried to fix and failed, perhaps. Or it could be something around here, and there's a little bit of corrosion just on the edge there and on the bottom pins. But you know what, it doesn't look too bad to me at all, so I'm just going to test on connectivity and inspect with magnification, but I'm assuming that that's not the issue. And then the next thing, as I say, is to remove that one, and then maybe these two. Yes, on my corrosion hunt here, speculating it might be corrosion. I don't think it is. I think I've got a bad connection somewhere, or connected something to the wrong place. There's not really anything here. There's a few pads to tin up, but I've checked everything around here, it's okay, so I'll tin these few bits up. The next thing I'm going to do is get that off there, because it is pretty corroded around that, surprisingly. You know, like the Agnes socket was alright. You know, it was so flush with the board, the corrosion stopped, but it seems to flood maybe up this way, because that is far worse than these two looked. So, and that's related to the CAS stuff, I think, or maybe RAS. I think it links to this 7.4 up here. So, I'm thinking maybe something here, so I'm going to get that off next. Going to desolder, I think, rather than use hot air, and just see if we can get it off the traditional way, just the same way I did the sockets for the RAM. But I am getting to the point where I am considering giving up with this, actually. I did say initially to Kathas, well, I started with, I was like, I don't want to work on this is going to be way too much work. And having spent 2 to 3 weeks on this, yeah, I'm thinking Amiga might be an idea, but you know, I don't want to do that. That's not my thing. And what I mean is, you know, taking all the components off a board like this and putting them onto a brand new board. I don't really like builds that are so large. I've got a board myself to build for something else, you'll see, which you could argue goes against that point. But it is not something I'm looking forward to building at all. It's like I keep putting it off, putting it off, putting it off. The traces run so close to these connections. I mean, you could argue, well, that's the same with any 2.54 pitch board. But yeah, it's easy to scratch the solder mask off when you've got a really, really, really fine nozzle. Well, hopefully you can see why I wanted to take that off. Yeah, it was pretty dirty under there. The question is there any corrosion? Maybe not. Or was it a bad chip? Anyway, yeah, it's the repair that never ends, this one. Right, the following day I am making some gradual progress with this. Let me switch this off. I got the RAM back on here. Yeah, there was no real damage around there. Things didn't improve at that point. But when I turned the board back over, I noticed a tracer just completely torn near the RAM here, somewhere in the middle here on the other side. So I wondered if it was that. Fixed that, didn't seem any different. And then I started testing the address lines, something which I'd done before and I hadn't really paid much attention. Logic probing the address lines is like pin 6 on the RAM here, up towards the end. I think it's like 6, 7, 8, 9 or something like that, 4 bits, and then it follows around the other side from the pin 11 or something like that. Anyway, the first one, pin 6, it was like low, showing low. Now, I'd had the resistor array off at that point, I think, and I noticed it was, I think I tested connectivity between there and, I think it comes from Agnes, yeah, it comes from Agnes. So, you know, the RAM address lines are produced by Agnes, and they just go straight to the chip RAM here. And that pin 6 was not joined. Yeah, so I joined that up and we've got a little bit further, but there's still an intermittent connection somewhere because pressing can influence behaviour, and we've got no text. So if I switch it on now, you'll see we get the green and black flash in just a second, then we get these purple bands. This is normal in the background. Normally you should have a black centred part there with text. We haven't got that, so those colour flashes are normal, I think. Yeah, and then no text. And the video, then fails, you know, it's gone completely. So I think maybe there's some sort of interface to the chip RAM issue, whereby the chipset can't properly access the chip RAM. It's got to be something like that, because the connections around Denise seem alright. I've also swapped out Denise and I swapped out Paula earlier on, just to rule them out, and the chips are good. well, I think they're good. That is, I put new chips in, the behaviour's exactly the same. So yeah, that's not the issue. I'm not so sure about the green and black flashing though. Should that be really quick? I honestly can't remember. I think it is. I don't think it's supposed to go like green, black, green, black, green, black for a few seconds like it was doing. We just get a quick green, black flash and it goes red obviously if there's a problem, and there isn't. You know, that's not happening. And it's consistent, as you can see. Well, pretty much. Occasionally it seems to hang a little bit, like it's stuck on the purple screen a little bit there, doesn't it? But then these flashes from copper I think are normal. And that's where those are coming from. Those coloured lines are being done by the copper in Agnes, so that shows the Agnes side's alright, but Denise, in terms of its interface to the RAM, doesn't seem to be. So I mean, it could be a connection still somewhere around Denise, it could be a connection around the Agnes, but it could also be the bridge stuff that, I don't know, I'm thinking maybe around one of the two gals, maybe a connection there. And what led me to look at those connections with the RAM, I thought, well, we've got a RAM issue, so let's start looking at the RAM stuff. So I started with the 373, yeah, that chip there. Now that's a new one, put a new one on there, same behaviour, and I'll leave that on because it's got longer legs. So I tested the connectivity. Now it's pretty hard without something like PCB Explorer because all of the pin numbers are not listed on this diagram here. The connections on this side, yeah, I think ultimately that's where one of them was missing, actually, because obviously it wasn't going through to the RAM. You know, the first address line here was, you know, I followed it through the resistor array, and it was really problematic to try and follow it. It's like, you know, one of the pins goes to one of the resistors on here, and then the one goes down here, and they go all over the place. The traces zigzag, and you can't, you know, there's no layout thing for this. I'll show you the website that I used from Chucky's Component Explorer. That helped me a little bit, but trying to follow it and follow the wires and follow the traces when there's so many components packed into such a tight area, it's really hard. So it took me best part of about an hour and a half to fix that one trace. Yeah, so just looking at the schematics here, you know, we've got the green screen that comes from Kickstart. It usually indicates a chip RAM fault. So there are other causes for that. You know, obviously address decoding faults can cause that. Problems with one of the CIAs can give you that as well, not to mention a faulty Agnes. But nevertheless, chip RAM. So looking at the chip RAM page here, yeah, I started by looking at the address lines there that go into the latch, the 373. So yeah, there's a bus CMA that comes from Agnes, and then the other side of the latch there, it goes to DRAB, which is the address bus that goes to all of the chip RAM. So yeah, that's the obvious one to check, and it's fairly easy to do because it's 8-bit. Now the interesting point I'd make there is one of the address bits, I think it's the uppermost one, it doesn't go via the latch, it seems to go straight across. Yeah, and that helped me work out the connection I had there, the issue around the latch. But as you start to look around that, you can see other things on this page. There's a lot on here actually to do with just the memory. This is just for chip RAM. And the F86 there's some important signals come through. You've got a RAS signal, C, RAS, chip RAM, RAS, presumably chip RAM write enable, and then the read write, which performs BRW1, which goes further down. I think it becomes one of the inputs, so output enables or something for some of the RAM stuff here. So the bottom line is you've got to check the latch in this situation here, the F86, and of course if you've still got a problem when you checked all the connectivity on here, you need to go back further. You know, I might need to look at some of the inputs to the F86 and stuff, scoping those, logic probing those, and see no activity or high impedance connection. Well, it's going to be, a missing trace, isn't it, if it's high impedance, but you can see a low somewhere or a high and think everything's alright, and actually you just, you realise you might realise you've not got a signal going in and it's just pulled up by a pull-up somewhere in the circuit or something like that. So yeah, very time consuming and problematic to work your way through a corrosion repair like this. But the interesting thing with the RAM, there's two banks of RAM here. It's I mentioned earlier, it's like 32-bit chip RAM on this, so you've got two 16-bit banks here. So the top half of this diagram, you've got D0 to D15, and the bottom half is D16 to D31. And in between these two halves are some 74 F245s, U257, U258. So the way those work, if you look to the left side, it's controlled by the bridge side of things. In a 4000 you've got bridge it, This functionality is wrapped up into Bridget along with the chips to the left there, 74F646. Those were all merged into Bridget on a 4000. But the 3000 obviously was the predecessor, and this is where they started in terms of, you know, having the bridge stuff here. And what is the bridge stuff? Well, it's a window into the Zorro side, as far as I understand. You know, it's a bridge between one bus and another. And essentially it's what makes this 32-bit. What that does is it connects both these banks up to the main data bus there, DRD 0 to 15. But yeah, those 245 sit bang in the middle. So in order for, you know, a 16-bit, you know, a lower word read of that upper 16 bits there to pass the data through. And I think that's, you know, that seems to be how this works. It's, even though it's 32-bit chip RAM, it's read in two 16-bit halves, isn't it? So DRD bus on the right there, I think that goes to the chipset, doesn't it? Whereas on the left-hand side, you've got, you know, a bus of 32 bits, that's 0 to 31. So the main CPU reads are done by the F646s on that left side there. Yeah, so the four F646s are used to read the, you know, specific, you know, upper byte, lower byte, upper word, lower byte, upper word, upper byte of the two, you know, banks here, the two 16-bit banks. So that's how the CPU reads those. So there's, you know, there's a number of components there, aren't there, that could cause all sorts of weird and wonderful problems. You've got the 245s that sit in between the two 16-bit buses of the RAM there, the DRAM. But you've also got the four F646s that are used for the CPU to access this data from the two banks as two, you know, separate 16-bit words, upper and lower. And the F245s sit bang in between those two 16-bit banks that presumably allow the chipset to read the two halves independently. You know, it's two 16-bit words, because the chipset for Agnes and stuff on there, it's going to be 16-bit, it's not 32-bit. That's the thing. So that's why you've got that complexity in the middle. And of course the bridge signals to the left there are used to control the output enable and presumably direction and stuff, and you've got some other control signals there. You've got O, E, C, D, DSAC 1, which is bus protocol stuff to timing of data access. Yeah, and then you've got that BRW1 as well, which comes from the read-write, so everything's synchronized in terms of you know, reads and writes and stuff like that. The bottom line is it's reasonably complex. There's quite a lot of things that could go wrong around there. Anyway, so where I'm going to pick up here now is we've ruled that out. We know that we think the RAM connectivity here is now good. So there's this chip, yeah, and these two. Those are what I'm going to focus on next. I'm going to logic probe around here, see if there's any high impedance. That's the other thing. Logic probe is your friend. You know, probe the vias, yeah, probe the connections around the pins. If you see a high impedance connection, it needs further investigation. Flip the board over, probe the via on the other side. Do you have a signal? Oh, you have a signal, but you don't on the other side. You know, you need to block that via. So yeah, and ultimately that was what the issue was with this connection to here, by the way. There's a via somewhere up here, and it looked perfect on both sides, and I think I measured it and it was alright. I should have blocked it, really. And that was the issue. It was that via, but I just routed a wire directly from over here straight to this chip, I think. Or it might have gone to the resistor, I can't. No, it went to this chip, that's right. Anyway, I'll report back when I make some more progress. And I guess I can show you the process of logic probing here. So just check in any vias and things we see. But if we go around this 86 here, it's an XOR. Now I've got, I think, an LS instead of an F, so that's going to need swapping out. But that, I don't think that's causing us our problem, the fact we've changed from an LS to an F. Yeah, so I'm not seeing any floating connections there. That doesn't necessarily mean what all the connections are there. It could be that there's a pull-up going to a pin or something like that, or a pull-down, which means you see a signal, but elsewhere, something else is not joined up to that pull-up, if you see what I mean, the other side of it. Or the same side that goes to the pin, is what I mean. So yeah, there's no issues there now. We know around that is okay. I mean, I could check that as well, just to be double sure, but I'm darn sure that's alright. Because if we were missing one address bit there that goes through that to the RAM, we'd be getting the red screen again, so it's not going to be that at all. Yeah, and obviously ground and VCC. Now the stuff here, I'm not really paying much attention to at the moment. And these two chips you may be wondering about that are missing. That's the real-time clock chip, that's the decoder I think, or the, I can't remember what it is now, 174 for the real-time clock. So we could just remove those. And technically we could remove these, because I think this is just for the scan doubler side of things. We could be unlucky and maybe one connection goes through this inverter here. I mean, the connections there look alright. I mean, at some point I should try and get the RAM back on. What's that? Yeah, we've got a pin up there that's floating top right. So it could be missing an input or something there. But I think that that's just scan doubler related stuff that's been flowing, look. So yeah, we've got a couple of floating pins on that, but I'm fully expecting that's because there's stuff missing around here and maybe some damage that needs patching. And again, like I said, this is, I think, that's flowing, that's flowing. I think it's for the scan doubler stuff. That's flowing, that's flowing. Just testing temperature while it's on like that. You know, the stuff over here on the right hand side gets a little bit warm. So there could be a bus conflict occurring at some point there. I don't know. But power cycling it, we get the exact same behaviour, it's repeatable. Yeah, so I think I'll check out the connections with these next. Right, so getting nowhere, trying to understand what the final issue with this is. Yeah, you can see I've been removing the nail polish and putting some solder mask paint down, UV. So I've got one of these UV things here. And yeah, it's a case of trying to balance it with a scaffold over there for, I don't know, maybe 3 or 4 minutes, and then use some hot air, 100 degrees, use the UV light and the hot air for, I don't know, maybe 20 or 30 seconds, and it dries really hard. So yeah, I'm removing the nail polish, just a bit of acetone to clean that off. I'm going to be shortening up the wires, tidying up the solder points, but just checking everything as I'm going along here. The main reason for me to remove the nail polisher a minute ago was just to check everything that's underneath it. I wasn't 100% sure everything was still right, and it was on those 2 bits I've done. So I'll do this bit next. I'll perhaps show you removing the nail polish with some acetone. Oop, sorry, let me shorten the meter contacts together. Right, I'm warning you, it does look a war zone down here. So just move this out of the way. Try not to touch the solder mask paint. So you can see the little bit I've just applied is there. Yeah, so we'll heat 100 degrees. You can see it sort of reflect the light a bit when you move hot air over it, so I can tell that it's still a wee bit liquid. But yeah, just swap between you know, bouts of 100 degrees for maybe several seconds, get it nice and hot, and then UV super close, because this UV pen here is not very strong. If you wonder where I got that UV pen from, I've had it for about 15 years actually. It was when we had a cat pee problem. One of the cats was peeing around the house, and yeah, we got one of these cat pee detectors, and it's just an ultraviolet light, and it will show up any liquids and things really easily, even if you can't see them, and even if they've dried. The remnants, you know, the, what do you call it, residue, is illuminated by ultraviolet light. So yeah, they're dead cheap, these things, about £10 only, £5–10. It's just some ultraviolet LEDs. It's hard, I can tap it. Yeah, that's dried, great. Now what I'm not doing is covering all of these traces here with solder mask, because I want to be able to test from here down to here. Yeah, I might just cover a bit more later, and I might cover some of this up here. But yeah, I'm just going to use this to secure any really fine wires on traces, to fix traces. Wires themselves, when I shorten these and tidy up the solder points, I don't know, I may use a tiny little bits of hot melt glue to secure them in places maybe. Aha! Well, it is an Occam's razor. I'm glad I'm doing this, because in the process of redoing this, I'm testing all the connections. I just tested all of these traces here just by following the connections, you know, checking from here, I'll see if I can show you, here to, hang on, one of the pins up here, like that, and then go to the next one, and then the next one, and it goes down here I think, and the next one, down here, and all the way around we got to the very, very last pin here, which goes right up here, and there is no join. If I do the one next to it, we have a join. That one, no join. So there you go. I think that maybe is the issue. So I'm going to join a wire from there to there, but the other thing you can see, I've got, you might be able to see, so I'm a bit distant away here, 3 really fine wires on these traces here, because the point where the pad joins the trace, it just detached. So it's really fiddly to do. Do you join a wire from here all the way over there? You end up with crazy amounts of wires, so tiny trace fixers there. So I'm just going to cover those right up to the actual pins with a bit of UV stuff as well, and obviously I'll show you removing this. In fact, I'll do that now. Let's just do that now, because I've tried a few different things in this video with little success. Like, you know, we tried the Loctite, and that made things really bad. You know, it created me a huge problem. And nail polish, yeah, it's alright, but the colour never matches, does it? And then it is a bit soft compared to solder mask paint. So you can see it just comes off, yeah, with a little bit of friction. Let me zoom you in. But yeah, you'll see that you can just have a little rub around with a bit of this stuff really carefully, because obviously I've fixed traces and things around here. And it starts to come up. Anyway, I'm going to need to use magnification just to make sure I don't damage anything here. But yeah, I'll remove all this, we'll fix that trace, and then I'll report back. Switch it on. This is my first power up. Is it going to make any difference? Nope. Well, it has made a difference. The bars are more stable, if I'm honest. But we still haven't got text. There's things doing my head in with this. I'm guessing if I had a serial connection now, I'd probably say everything checks out alright. I'm tempted to just put the original Kickstarter ROMs back in, because you never know, it might actually work, but without any graphics. Do you know what I mean? You might get like the purple background, and then the floppy drive might start to seek, I don't know. It's annoying. Anyway, at least that's something else fixed. I suspect that that was the intermittent trace. You know, I've been tracing or following an intermittent connection where I would press on different areas of the board, and yeah, just pressing around now, it's not having any effect. So I think that was the intermittent connection I had. But we do still have yet something else to fix somewhere. So it must be around 3 weeks I've been working on this, believe it or not. Very little else apart from our 1084S that blew up in the middle of it. And the reason that blew up, I was trying to connect it up via serial to the 4000. So you can see we're getting some weird and wonderful things, but believe it or not, this is kind of positive, in the sense that when you first power cycle, green black, that's testing the chip RAM. It would go red if there was a chip RAM error. Green means good. Normally here there'd be a screen of text. The text is like not displaying, but just like messing around with the board, and I'm talking about mostly with just like some warm air, hot air, you know, if I heat around the side where the deinterlace stuff is, and sometimes around the chip RAM as well. I can't really work out where it is. Sometimes you might just get like half a screen of text. I saw like the status line at the bottom showing the number of RAM and some debug information, then it just went off. It was like literally one frame, which is why I'm now resort to filming it, just to see if I can actually see any normal signs of stuff there. You know, if I do capture one frame that shows me that actually it's kind of working, but we've got this graphical issue, which is a given, isn't it? You know, we do have a graphical issue. And you think, Denise, well, you know what, I've tested every single connection on Denise, every single connection between Agnes and Denise, every single connection as far as I can tell between Agnes and the chip RAM, every single connection between Paula, Denise, Agnes and the chip RAM. I think some of the connections may go that way. I don't think they do, actually. You know, like the RJ bus for the address lines, and there's DRD, all of that stuff looks good. So I'm completely at a loss to understand what's going on here. Like, is it a bad Agnes? It could be. The next thing I may have to do is take up the nice kind offer from, I think it's TIU on my Discord. He's the guy who's created an adapter from the 8372B here to an 8375, I think. So I might have to do that. I really don't want to have to take that socket off again, because that's a new socket. There's one or two fixed wires on that. I saw a bit of screen of text there while I was messing. Yeah, take that off, put a module on that allows an 8375. Because the other thing is, once you've done that, then the 8372 can't go back on. And if it turns out that's not the issue, it's just frustrating, really, isn't it? And it means that Chris the owner of this won't be able to stick the 8372B back on. But I mean, he could always sell that as a spare, maybe. You could argue it'd be a good idea to have an 8375 socket there. So I don't know, I might just do that anyway. I'll speak to Chris first. But you see, if I had that serial interface here to the 4000 over there with the 1084S, I would be able to get a bit of diagnostic information. Well, I've lost my cable, my 1084's blown up, so it's not going well. On top of that, my gate blew off, the toilet's knackered, and there's a list as long as you can imagine of things that are just building up, as well as a pile of things that need unboxing, including an amazing microscope donation, which yeah, that'll have a video on its own. I really can't wait to get that out, but it's not even been unboxed. I haven't unboxed it yet. I'm really sad to say. I've got some PC cards for the Amiga as well that came from Stefan. I've got one that came from Chris Edwards, and some disk drives, some Archimedes, and I just have no space or time until this comes off the bench. So as you've got the 1084S monitor fixed, the next thing I'm going to do, picking up this now, is to clean around the slot there. Right, making some gradual progress with this. I've been scoping everything. I found a problem with one of the signals around the PAL here. Yeah, and it was another bad via, so fixed that. Everything's looking fine though. It's hard to work out, connectivity wise. It's hard to work out what's going on. What we do know is we get the green black as it boots up, and it doesn't go red. Now, if I swap these PALs, as I've mentioned a number of times through this video, for new GALs, we get an instant red screen, which I don't understand. The GALs should work. The speed of them is okay. I've to choose two different sets of JEDECs. I've double checked the part numbers. So I don't know why, but my GALs do not work as replacements here. I've got to theorise that maybe they're slower than they're actually marked, or something like that. Maybe they're too fast. That could be a thing. And again, they could be marked correctly. Maybe the dash 10s instead of dash 15s. But dash 15s apparently should work here. I think they've got to be 25s or faster, something like that. Anyway, coming back to the RAM again, even though the RAM test passes, one of the things I noticed, I was checking out the DRD stuff. So you've got the data bus connection, which is on the Agnes side. Yeah, it's the data bus that comes through Agnes effectively. That seems to be where the issue is, and that would kind of correspond with the fact we've got no video, because unless Denise, because I think this is how it works, I think Denise does its memory accesses, chip RAM accesses via Agnes probably, then you'd get problems with graphics, and that's what we've got, haven't we? We're at the situation where the RAM test's alright, and then we get graphical problems. Now, what could cause that? So I was thinking buffering. I'm thinking of the 646s and the 245s that sort of sit right around the RAM there in the middle, buffering between the chips themselves, I think, and the rest of the system. If we look at one of the data bus connections here, let me just show you. Right, switching the power on. Just going to probe pin 1. Do you see what I see? Look where the marker is. In fact, I'll just go to one of the end pins. This is an address line. Right, so look at where its ground is. It's in relation to that 1, I think it says on the left there. Yeah? So that's a full level, normal level signal. Like CMOS or TTL. 4.4 volts. Yeah? We go back to pin 1. This is one of the data bus connections on it. Can you see how it's, look where it is? It's kind of going the mid. We've got some higher peaks and then ground. So we've got like a voltage level issue. Now there are a number of things that fit on that DRD bus, and I think what's happening here is we're getting some bus contention. I've taken the probe away now. So for whatever reason, I think on the DRD bus, two things are enabled at the same time when we get in a halfway point at some point. So you've got ground where my thumb is, and you've got your 4 point something volts up here. Yeah, you'd expect the peaks to be between those two. What seems to happen occasionally, it comes down to about halfway, and then it comes back up, and it comes down to halfway. So there's something on the DRD bus interfering. That would kind of explain why we're getting no video. I still haven't found a serial cable. If I had a serial cable, it would be so much easier. I could go and make one. I've got connectors. I'm just being lazy. And you know what? Sometimes I just prefer going about things in a different way. I prefer to just go blindly with certain things, but follow a symptom. And I think I found a symptom. Yeah, the DRD stuff, I think, is the issue. So I'm not sure where I go from here. I've ordered some 646s. These ones back here, to get warm after a few seconds. That could be a clue that there is a conflict on the DRD side here. So anyway, what I'm going to do is just recheck the schematics here and just double check that everything in terms of the output enables and direction pins on the chips that are relevant around here are correctly coming from the proper places, which are probably these. And because of the weird issue with the gals not working here, I haven't completely ruled these out yet. What I really need to do is get some proper gals, I think, that are known to work here, and then if we still have the same issue, at least we know that isn't the issue. But I've scoped the connections. The inputs are on the bottom of these gals here. It's just PALs, these are the original ones, but gals are the same thing, you know, it's the same to pin out, and you tend to find the inputs are along the bottom. I think you have ground on the bottom right, and then the outputs, or IO pins I should say, are on the top there. You might even be able to reconfigure the inputs as outputs. I don't think you can though. I think on these it's inputs on one side, outputs on the other. And another obvious thing to check here. So looking at the one of the data bits on the chips on the left bank here. So you can see we've got the level issue there. Then go to the next bank, so the next column of these. Look, same problem. The next column, power cycle in between here. This is the third column, same problem. Fourth column. Now why is this relevant? Each of these columns, and I'll show you where they are in a sec, represent a separate byte in the 32-bit long word there. Because believe it or not, this has 32-bit chip RAM. It's one of the earlier Amigas that has 32-bit chip RAM. So that's quite useful information, because there's going to be some, you know, you've got UDS and LDS on the original 68K, which, you know, dictates whether you want the lower byte or the upper byte of a 16-bit word, yeah? We've now got a 32-bit word, so you're going to have UDS and LDS, but then you've got like something like UUDS and ULDS. I've probably got the acronym wrong there. In order that it can work out which byte it's dealing with, or which 16-bit word. So the fact that all of these look like we're seeing some contention where we've got, you know, a line in the middle, it's bobbing up and down between a sort of middle line, kind of makes me think more about the control of these, rather than the fact that both of the transceivers, you know, both 16-bit wide things here are balked, if you see what I mean. So I went to Chucky's Component Checker website. He's got a web page here where you can see the layout of the boards, and you can, I don't know, search for a component and it'll show you where it is. But I actually did a right click save, and I saved the top side of the board, the bottom side of the board, put them on my phone, and then used that. You know, you can zoom in, pinch and stuff, and scroll around on your phone to actually look at the PCB fairly close up, and the layout very, very closely follows the Rev 9, and that's what this board is here. Here's a Rev 9. It follows it very closely. Yeah, and that really helped significantly actually towards the, you know, the second half of this repair here. Oh my god, I think I finally fixed it. So I'm thinking that the RAM I was using was one of the issues. There was a bad connection on this pin here. I found a wire that shouldn't be there on that. All of this just from you know, scoping, so I'll show you some of that in a sec. Hang on, let me turn that music off. It's no computer. I'm going to get a copyright strike on it. Now this is quite frankly incredible moment. Now obviously we've got half the RAM missing. Haha! It's booting! Fantastic. So yeah, we've got some fast memory detected there. Wow, that has been an absolute nightmare. Seriously, that has been the hardest repair on my channel, hands down. Yeah, corrosion on these is not fun. Seriously, not fun. On an A500 Plus, there'll be a link top right. When the corrosion from the battery leaks on the 500 Plus, you've got Gary and some 7.4 series, and that's pretty much it. So it's far, far easier, and you know what, you'll spend hours and hours and hours trying to fix a really badly corroded one of those. But on something like this, everything is really tightly packed around here. There's so many, you know, small caps, resistors, and the components are all like really packed in. You know, there's no gaps between these sockets here. Yeah, so I've still got a lot, I mean like a lot to do on this, but right now I am going to celebrate. It boots. Yay. So let me go get the Amiga 2000 keyboard and see if that works. Now there's a question why my gals don't work. I'm going to retest that in a minute. Let's just switch it off. And obviously we've still got an issue here in the sense that we've only got half the RAM, but I think maybe my RAM is the wrong RAM. I think this has got weird RAM. I don't think it's the same RAM that's on a 500 Plus. I think there's something different about the RAM on this. So that's normal, because it's only got 1 meg, I think. And in fact, I didn't see, did it say 1 meg chip down there, or is it half a meg? I don't know, it should be shown. That always makes me laugh. Available. Yeah, you've got a typo there, Chucky, you need to check that. Yeah, we've got 1 mega chip. So let's just see, can we go up and down? Oh, we can. Oh, wow. Let's do CIA tests. Test CIAs. See if that's alright. Oh, that's incredible. But I tell you what, I have sweat, blood and tears repairing this. It's been over 3 weeks. I'm talking about almost every day I have had spare. I mean, the last 3 or 4 days I've been on this pretty much solid. Hence, you know, why there's been fewer videos out. But you know what I like? Determined. When you've got determination and you don't give up, you'll always get there in the end. So CIAs are alright. Sound isn't going to work. I've not even got cables connected, so we'll do that later. But the sound area is going to need some further work. Let's just test the fast memory. Memory test. Non-usable 4 meg. Just over 4 meg is non-usable. So that's not good, is it? The RAM just may need reseating, but we do have a fast memory issue. So I think the next thing I'm going to do is have another clean around here again. But you can see I took the RAM out. This was the final thing. I thought, and I'll show you this on the scope perhaps in a minute. I was probing the database. Yeah, in fact I showed you, I think. I was probing the database on all of these here, and it was kind of like midway level, and I was like, what is going on? Now at that point I realised there was a bad connection here, but I tested with the new gals and stuff there. It fails in a different way there. Those may now work now this RAM's not here. But the RAM I had here, that was one of the recent things that just like a few days ago, which was take the old RAM off and put some RAM that you get on a 500 Plus, which I thought was the right one. Is it 44256 or something like that? And it could be that there's still a problem here with this bank in terms of something else here with the address decoding or something, but it could also be the RAM. So I'm going to get this original RAM back on. Right, RAM installed. Just doing a pin 1 check, they're all okay. Now if this works, either one of my RAM chips is bad or it uses oddball RAM. Now we've got a RAM error still up. So that is interesting, isn't it? I still think the RAM is different because now it's actually booting. It wasn't booting with my RAM, my other RAM. So yeah, we got 1 mega chip still. Right, let's just do the chip RAM test again just to see if it affects the video at all. No, so we do still have some kind of glitch occurring somewhere from, I don't know, a bad trace or something perhaps. Yeah, anyway, I'm still confused with the RAM. I'm going to need to go and ask some of the guys in my Discord, I think. Because this is 32-bit as far as I can see. You know, you've got the full 32-bit wide data bus connecting here. It's just weird to me that you'd remove that and it go, you got 1 meg. And then you fit it back in and it goes, you got 1 meg. Is it okay, so we still got 1 meg but now it's 32-bit? Because this doesn't report that, I don't think. It just goes, you've got 1 meg. But it is a 2 meg. Agnes, so I was kind of expecting to see 2 meg, to be honest, but maybe accessible in 32-bit. Now we've actually got some errors coming back there, so that's interesting. Yeah, good block start, ends with that size of 1023. So I think that this is onto the next bank now, isn't it? So you know what, maybe we should have 2 meg here, and maybe some of this RAM is bad. I mean, we've got quite a lot there, haven't we? That's like 2 chips worth, well, 3 chips worth, 3/4 of that RAM potentially is bad. I'm going to say 3/4 of the RAM, talking about 1 bank here, I think. What might be an idea now is to remove that RAM again and just do the same test, just to work out which bank of chips it is here that's actually giving me that error. After taking out every single RAM, testing the first 4, then the 8, I'm adding the 12th mag here. Can you see there's a pin totally flattened down there? That's the issue. I think it wasn't in the socket, so I need to you know, use the pliers and pull that pin up and straight. You might not be able to see it very well there, it may blur a bit, but yeah, squashed down. And the 12 meg now checks out fine, so that's another problem down. yeah, so we made some good progress in this part. The board is sort of working, but there's another problem, and it's not really corrosion related, I don't think. It's actually a fault, another fault, and a number of other things that we need to fix and talk about stuff in the next part. So I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Thanks for watching. I'll catch you in the next video.